ಸಜಿನಿಗೂ ಸಜಿನಿಗೂ ಅಂತ ಇಲ್ಲ ಅದ್ನಂತ तुमने कंटेंट नोटिस मेकेल हेल्प एक्सपेक्ट करना चाहिए एकदम दाट एक दोन पण ज्याला आमचं सांगितलं एक्सपेक्ट करणार एक मेकेल टेबल एक पिन बी हा आपुडच्या बिना आपुडला मग कसं ऍक्शन घेतलं शिगत म्हणा अद्नंतर तुमचं कसं म्हणा दाखवतो
तेच नाही तेच म्हणाला
भेटायला काय माहिती मोजत ना लास्ट टाइम फेअरवेल इश्यू जगडी झालं पण आता सांग कसं की मी विघ्नेश अलगंगे जगडी झालं त्यांनी जॉईंट केलं हा आता जॉईंट करून मोठं ग्रुप हे करतात त्यांना ते जॉईंट करणं मर्याद सांगितलं त्यांनी जेव्हा त्यांना आम्ही जेव्हा केलं सांगू मग ब्रांच ट्रिक मग
ఇంట్లో ఉన్నప్పుడు యూజ్ చేయాలి.
Good morning, everyone. On behalf of G. Pullareddy Engineering College, Department of Computer Science and Engineering is organizing a 6-day FDP on cloud computing. In this regard, I welcome Sridhar Chittraju, today's speaker. Good morning, sir.
Very good morning.
Yeah, I will request everyone to mute themselves. I request P. Sri Lakshmi to introduce today's speaker. Sri Lakshmi. P. Sri Lakshmi.
Good morning, one and all. A warm welcome to 4th day of FDP on cloud computing and its applications. I, P. Sri Lakshmi, Assistant Professor of CSC, G. Pullareddy Engineering College, Kurnool. It's a great pleasure for me to introduce today's speaker, Mr. Sridhar Chittraju Garu, Program Director, Chief Technology Officer, Center of Excellence, Kindle. Sridhar Chittraju Garu is a technologist by profession and he has more than 26 years of experience in IT. He has worked with Tata Consultancy Services in various strategic roles for a decade before joining IBM in 2007. He has experience in leading teams for the client engagements and development programs in the state of the art, cloud, edge, IoT, 5G, blockchain, Web 3.0, and AI/ML technologies. Sridhar Garu believes in lifelong learning and incremental growth. His interests are non-fictional books reading, Indian philosophy, and trekking nature walks. Sridhar Garu obtained his master's degree from the Indian Institute of Technology, Bombay. He also did an executive management program from the Indian Institute of Management, Bangalore. His motto is, "Today is the first day of the rest of my life." His passions include building high performance teams and enabling technology innovations that help transform business worldwide and the societies we live in. So I request Sridhar Garu to take over the session.
Hello. You're able to hear me now?
Yes, sir. Yes, sir.
Yeah, thank you, ma'am, for that wonderful introduction. Thanks to GPREC for giving me an opportunity to present the greatest intellectual audience here. I have always high regards to the team, right, teaching staff, right, wherever I go. They are in the noble profession, always help to bring the best of abilities of their students. So here I got an opportunity to share some of my knowledge to each of you. Thanks for this opportunity. Today I am going to cover on the topic edge computing. So that what exactly I would like to cover in this topic is the cloud computing. We all know it is in the mainstream now, but with the newer technologies coming, and the compute power is moving from cloud to edge. So I'm going to cover about the edge computing and some of the use cases, how it works together with cloud computing and brings the best of applications and use cases for us. So there is the topic. once again, I am Sridhar Chitraju from Kyndryl Corporation, and I'm here to present on edge computing. Thank you. So moving on. So have you ever ordered food and waited for so long in a restaurant? Maybe it happens, right? For example, right, I visited a busy restaurant, very famous restaurant in Hyderabad, and ordered chicken tikka masala. Assume that I was waiting for it and it is taking forever. It is taking very long, lot of delay happening. And I'll be wondering that most probably they went out to catch a chicken before cooking, right? Sort of idea I'll get into, right? We will not be waiting forever for the services to be delivered to us, right? The delay certain times is not acceptable for us. And here, if you see the other scenario here, the restaurant people are waiting and it is taking so long, they ordered pizza from next door to get it delivered. So we are impatient, right? We want services to be delivered quicker way. We cannot go and stay in the restaurant for a couple of hours and so. So you might be wondering how it is related to edge computing. Okay, let's see another analogy. You visited an OPD department of a busy hospital, right? Corporate hospital, where first thing what will happen, nurse will come and she will take all the vitals, your temperature, BP, right? And maybe glucose and height, weight, and so on. And then she gives this the vitals to the doctor. Then doctors will go through these vitals and quickly get into the examination mode and gives the best of his services. So what we are doing here, the nurse is helping, acting as a intermediate source, do some checks and balances. Otherwise, the doctor will be bombarded with everything, right? Doctor has to do everything from looking after the vitals to examining the problem and giving the prescription and solution, right? What needs to be done. So it cannot be done, right? We are choking the doctor time. So doctor's time and the specialist time is very, very precious. So that nursing staff is helping to create some channel. They take some load and passing out to the doctor so that they can give the best of their abilities. So you'll be wondering, right, why these two examples, chicken tikka masala and this nurse coming in between, right? So what is edge computing? If you ask me, edge computing is here for two things. So one is the response time should be minimal. Not all applications can wait even in milliseconds, right? Certain milliseconds will catch them a lot. So we'll look into some of the use cases, right? One is the time part, response time. Other one, load on the one central server. So we need to decrease the server load so that we get best performance and response time. So the first chicken tikka masala is the response time. We need quicker response time. Here we are reducing the load through the nursing staff to the doctor. So these are the two analogies you can think or connect with edge computing. So let's look at what is the edge computing as a definition. Edge computing is a distributed, distributed computing topology where information processing is located closer to the edge. So what is happening? Information processing happening closer to the edge, where things and people produce or consume the information. Edge is the where people are producing the information, right? Some data is being produced and it has to be processed, and if any decision making has to be done, it has to be sent it back to the same thing, right? Or the people. So this is the Gartner's definition. If you see Schneider Electric, this is also the same thing. Edge computing complements with cloud computing. So they are not competing, right? In the hybrid IT environment, while computing leverages centralized data centers, edge computing leverages the distributed micro data centers. Here, there is a distinction, right? Cloud computing, it is the centralized data center, whereas edge computing leverages the distributed micro data centers at the edge of the network. Edge of the network is when we have some information, it has to go and hit the network. The first point, right, that is the edge. Then it can go to the network itself in multiple phases and go and hit the core network on the cloud computing. So it can go to multiple layers. We'll look at it in detail. So it is hitting the edge of the network where data is closer to where it is generated. So if you see, main thing is closer to the computing is closer to the where data is being generated and consumed. That is the definition here. Let's look at IDC definition. Edge refers to enterprise hardened servers. Right? There are servers and appliances that is not core data centers. They are not core data centers, okay? But there are having some computing power within it. This includes server rooms, servers in the field, cell towers. Even cell towers will act as edge computers, and small data centers located regionally within the office, within the branch, within this region for faster response times. So if you understand, it is nothing but bringing the compute power closer to the data produced, wherever data or information produced and consumed. So we are bringing closer to that network edge. This is called edge computing. So all computing outside of cloud happening at the edge of the network. This is a board statement. So lot of newer applications, cloud native applications, right, are leveraging the edge network outside of cloud. So we get to see more and more applications and services being offered through edge computing in near future. So let's look at the history of the edge computing. Edge computing is not very new at all, right? It is been there in one form or another form. It is very simple concept, right? As you understand, it is very simple concept. We are thinking instead of sending something to the central server and bringing it back, we are putting something in between to process and give it. When necessarily only we go to the central server, right? Not every data and information we collect need not to go to central server. That is the principle of edge computing. So similarly, like when CDN, this content delivery network, been introduced by Akamai, right, in 1990. So they also find that if you need to start sending the videos or pictures and other things, content, right, more of content, we need to have local servers. We should cache the information so that instead of again reprocessing, cache will be there and it will quickly transmit the information or videos. So this is the Akamai. We started in 1990 and it been evolved into cloud computing, cloudless and fog computing. We'll look at some of these details in detail. And now today, it is the combination of cloud and edge computing coming and helping in the helping all the flexibility of the applications, the response times, drastically reducing the latency, low latency sort of applications, near real-time sort of applications are coming from the edge computing. So it is the complementing both the worlds to give best of services to us. It started in 1990. It's a humble CDN network. Even CDN network is there today. It got evolved with edge and MEC. We get to hear about MEC, multi-access edge network. So those are the newer technologies coming and helping in the video transmission also. Whatever Netflix, other video, the OTT things we see, they leverage the concept of CDN and with the newer technologies coming together through cloud and edge computing. So this is the history started from CDN to today, right? So one point it is being made from one of the executives from Cisco, isn't it easier to bring cloud to closer to the data instead of taking data to closer to the cloud, right? So what we are saying is data being produced from multiple appliances and a lot of data being produced. We are talking about gigabytes, right? Thousands of terabytes of data being produced today. 145 gigabytes per year. It is the prediction for 2023, 24, and 25. So we are talking about loads of data being produced in gigabytes. So instead of sending to central, we are keeping something in between as the edge computing to process. So instead of taking the cloud sort of capabilities, we can bring closer to the where data is produced, so that response time will be quick, low latency, and we can get best of services coming quickly, right? So we'll look at it very soon on that. So why edge computing is becoming very important now? In the past, it is there from CDN, I was telling, right? It is becoming more and more relevant and important now. What is the primary reason? So the evaluation of artificial intelligence, these mobile to mobile applications or services, device to device or mission to mission services, IoT and 5G are acting as a catalyst for a one HD cinema to download. With 5G, we are talking about minutes, 1 or 2 minutes, we can download a video, the picture, complete movie, right? So IoT, a lot of IoT devices are there, making our life easier, and at the same time, a lot of data being produced, and not every data need not to be sent to cloud computing. It can be processed locally, and there are a lot of devices like IoT devices or mobile devices at home or in the factory or any industry, even in retail shop, for example, right? Retail store, they can be interact to each other. And artificial intelligence, when data is there more and more, we need to get insights out of data, right? It can be AI, ML. These are the things coming and catalyzing the overall edge computing. So other one, all the businesses, whatever you name it, they are into have the digital footprint today. They cannot afford to say a traditional way of business. They need to have the digital footprint, and today it is estimated to be 40 to 50%. Okay, even in mining industry, 30 to 40% of their services or processes are digitally enabled. Right, we will not think banks. Definitely, it is 80 to 90%. That we are talking about fintech technologies and other things. Right, the digital business are touching each and every industry, and IoT and immersive experience. People want not patient enough to receive the videos and other things. They want immersed into the experience. Right, metaverse is coming into picture, and this AR and virtual reality sort of experiences is coming into picture, right? And the games, another thing, if you see the movies coming today to the special effects of the movie in the past, drastic difference. We cannot sometimes differentiate whether it is a real or the virtual reality experience. So we are getting immersed into the experiences.
This conference
right?
will now be recorded.
So those are all very important to be supporting the edge computing. So there are 4 imperatives driving the computing edge. What are the other things driving? There are 4 laws. One is law of physics. So this is law of physics. We want quicker response time, latency. It can be like when I say latency, for example, right? You have a robotic arm or something, and it has to be quickly react. If something is in the shop floor, it has to fix the problem immediately. If I identify a problem, it has to pick the product which is not good quality. It has to pick it up. So it should not wait for a long. It should not go to cloud computing and come back and take the action. It has to take the immediate action. So sometimes this robotic arm will have some of the computing abilities. With the speed of light, as soon as it identifies problems, it will go and react and pick the wrong product or defected product out of the supply chain. So this is the law of physics. So if you're talking about latency and other thing. Other one is law of economy. So anything being transitioned to the network means it takes time. Sometimes it has to go one direction from data, and once it processed, it has to come back. Right, so it has to happen both the directions. So this law of economy is how quickly the bandwidth part, okay? If you get into bandwidth, network bandwidth, if it is within our LAN connection, right? It is okay. It is not, it is quick enough. If you get into wider area network or internet, WAN or internet, it is expensive, and at the same time, it takes a lot of time. We need to cut down the bandwidth cost, and we need to cut down the distance it travels to the data to process and come back. So this is another law we need to consider, okay? Law of economy. Other one, law of the land. A lot of things, right? If you start putting everything onto cloud, it is center some other place, it can be a single point of failure. For example, you heard about this AIMS in New Delhi, their server been ransomware, been attacked, right? They are demanding $200K or so to come out. It is already 6 to 7 days now. So a similar thing happened in Karnataka. All electoral votes been taken by someone, right? The hacking into the server. So these things can happen if you have single point of failure. Whereas in edge computing, we are distributed. The data is there in bits and pieces, and same time, some security measures if you take, we are protected. So, and at the same time, for example, I am a bank. I don't want to send all my customer information to the other cloud sitting in another geo. So bank is here. I don't want to send all my data here. If they have some server here, right, they can send just here and come back. Okay, it is the branch office server they can have, so that any regulated workloads they can process here itself. If non-regulated workloads, they can send it to the cloud computing. This sort of privacy and security and the law of land will prevent. This is another law. Other Murphy's law, we all know, single point of failure I just mentioned and given the AIMS example. Lot of connections are grown. If a lot of data been produced, right, from multiple points, and we don't want one cloud here sitting and everything hitting bombarded with multiple times, right, the data and other things. So we want the connections are growing, and the connection can be vulnerable. It might be taking time. So single point of failure. So we can have the servers or fog computing or edge computing sort of servers closer to this in between the network, so that we can avoid the single point of failure, and at the same time we can increase the performance of our applications and so on. So what primarily we are seeing is latency, data volume. The data is being produced is increasing, and data velocity, how quickly data can be sent to the server and processed quickly and with insights. So this is the data velocity increasing. Transportation cost. If you start sending your data to farthest point in the network to the cloud, it will take a lot of cost. If it is closer by, it will decrease the transportation cost, and same time security also. Locality, for I just mentioned about regulated workloads and stuff. Local servers will give more flexibility to the companies and regulatory things. These are some of the reasons why edge computing is becoming prevalent. Then what are the benefits? Right? We already know why part we've seen. The benefits are very straightforward here. Let me cover some of the things, right? One is the faster response time. We want applications to be reduce latency and increase its speed. We want applications to be processed quickly and respond quickly. For example, you have voice assistant at home. You will go and ask, switch on so-and-so channel, right? If you say to the Alexa, switch on this channel, it goes to the cloud and it comes back. By the time it takes 1 minute, you will be feeling very bored, okay? Instead, you will go and switch on and faster response time. So those are the local devices which will help you to give the faster response time. Other one, reliability. So we are not sending the data across the connectivity, like a long distance. We are having the reliable connections between the devices within the perimeter. so that those are very reliable. And the same reason for security also, because we are not sending the data for longer distances, and we are maintaining the compliance within our LAN infrastructure for the companies or enterprises, though it is secure. And the same thing, it is cost effective. We are the bandwidth we are not using much for the longer distances of things, so it is cost effective. And other important thing is interoperability. We have too many devices coming together, which can have interoperability with legacy or modern devices. Whereas if you have only modern devices, if you have the cloud computing has to enhance to support these modern devices. So if you have intermediate thing which can cater to modern devices and legacy, if anything to be dealt with the legacy and the more processing, we can send it to the cloud. So these sort of benefits are there. One is lower latency, cyber security, right? We are connected within the perimeter, other thing, and we can do the data analytics. The intelligent devices are there, which can do some small insights it can bring and send it back to the data source or the application. If you are using mobile as a managed service for all the edge devices, we can get the insight on our mobile device. And interoperability, as I told, the multiple devices, but there is a lot of standardization being done for interoperability, and we are not storing entire data. Whatever action we have to take, we are sending that information and getting the insight and taking the action, and again it is being rewritten with the newer data. Not all the data, whatever we produce, not worth to store. We have to understand this concept. So some time sensitive data will be there. We need to act upon with the time sensitive data. For example, we are in a hospital, some vitals being taken, our heartbeat, SpO2, other things. They are all not required to be stored because we need to act if something going down, our pulse rate is going down or something, SpO2 was getting down. They have to immediately, some beep will come, people will come, rush to the patient and try to help them, right? That beep is the indicator, or it will go and hit the central server and send the alert to the doctor. Assume that the doctor gets the alert saying that so-and-so patient required urgent attention from you. So doctor can go and address the patient, right, immediately because there is some urgencies there. So these sort of things can be important. Not all the those, okay, in the vitals, right, what I just showed, heart rate and the SpO2, other things, right, BP parameters, other things, might not be stored for a longer duration. It can be there for maybe a few hours, right, because it varies. The whatever past history, 6 months, data maybe intermediate, every 1 hour it will capture the data and put it in another server as a record, patient record, but not entire continuation of record of data is not required. So this is the reduced cost of storage cost is also very important benefit we get from edge computing. Hope you are clear with this. So let me move on. Right? What? Thank you. Okay. So edge to lead from the front. Right? What few unleashed predictions was saying is today 91% of the data is processed from centralized data center. These data centers can be private data centers, which enterprises will have their own data centers, or they are onto the cloud computing. Cloud computing also centralized data center. So what IDC is forecasting is expected to be growing. Right, edge computing market will grow 250 billion in 2024, not far away. 2 years down the line, we are talking about this much growth. It is not only for edge computing, it is for different services, edge computing hardware and software and the services around it. Everything is expected to go 250 billion by 2024, the growth rate of 12.5%. Right. And the same thing Gartner predicts by 2025, 75% of the workload, enterprise data generated, will not be processed in the cloud. It will be processed outside of the cloud. Maybe the edge devices or the edge servers or MEC servers. We'll see some regional data centers or on-premise data centers to quicker processing, right? Not the full-fledged legacy data centers or cloud data centers. So the whatever 91% of data processed, it will bring it down to 10% in 2025. We are talking about within 2-3 years, we see a lot of action on edge computing. We also see further details on it, like how it is going to change the world we live in with the power of edge computing and cloud, the combination. So let's see, there are 4 primary layers in the edge computing. First layer, we'll have a lot of edge sensors and chips. So where data has been collected, right, with the sensors, and you send it to the edge devices. As I told you, health monitor or the watch or your laptop or mobile phone. For example, some sensors to the drone or automobile, even AR, VR sensors and stations, right? It can do the limited processing. It cannot do the more and more processing. If you want to do more processing with the data we getting from the sensors, the data can be further sent to edge infrastructure, where edge servers, other things will be kept. It is not sent to the central, but the edge server, where the edge server, it is the midpoint between edge devices and central clouds. So the latency is still 5 to 10 seconds, milliseconds here. So this is the another layer we are talking about, right? First one is edge devices, intelligent edge devices can do limited processing and send it back, take some actions or give some alerts. Further, if any further action, other things required, it can get it to edge infrastructure, which is still having a round trip less than 5 to 10 seconds, milliseconds latency. So this is also a very fast, near real-time sort of applications can use this. And if anything to be sent to further for processing in central cloud for big data analytics or something, we can send the data further to the cloud, and cloud can do the processing and send it back and so on, right? And you can get an alert on your laptop or mobile phone. So these are the 4 layers of the edge computing, and the response time and processing time will be the one of the key parameters we have to look at across these layers. If you go further, there will be delay. Here, probably 100 milliseconds sort of latency will be there. Here we are talking about 5 to 10 seconds, right? Milliseconds. If you have the regional data center, further little bit powerful on-prem data center, it will be maybe 50 to 60 milliseconds. So these are the different levels and the latency. And you could have been heard fog computing also, right? What is the real difference between edge and fog computing and cloud computing? We'll look at it in a detail in a minute. So the first thing is we have the multiple sensors, and even credit card processing. You went to the store and credit card, you went to the laptop and other thing. The edge devices will have some intelligence and quickly accept and do some few things. And if something is required, it can go to the fog. Fog is nothing but the lot of edge nodes. Okay, it will act as edge nodes or some of the devices coming together to do the service. For example, 2-3 services of edge nodes has to take action on one of the device action, right? That can be called as a fog computing. Fog is the meteorological term. Okay, so the fog is nothing but closer to the ground. The clouds closer to the ground. So the analogy here is the closer ground reality is the devices. right? So the fog, the cloud compute closer to the devices is called fog nodes. Okay, there is a lot of computation, little bit more computational power will be in the fog nodes. Here, multiple MEC servers and edge servers and regional data centers and those things will be there. And further, it will go to the larger data centers and cloud data centers. So for processing, this is the hierarchy. You can look at it. Okay, edge, it will be in billions in number. The edge nodes or edge service, edge servers and other things will be in millions in count, whereas in data centers in thousand to cater to all the applications across industries. Hope you are clear with this. Okay. And here the same taxonomy, whatever you looked at it in the other form, right? It is IBM given these definitions, and this picture is from IBM. Edge devices, a lot of edge devices between mobile and the robotic thing and the health monitors and automobile. So a lot of edge devices are there. It is billions. It is coming to edge servers and gateways. Fog computing, we saw this, right? They're in millions. And it can go to edge cloud. The fog will come combination of these two. Okay, these two is the fog computing. And then so some millions of servers are there. It can go to some of the intermediate cloud sort of server, virtualized server, which can do the processing and give it back the intelligence. And if further it will be hybrid cloud. So once again, it is in billions, millions, and thousands and hundreds. And so the same picture represented in the vertical form here. Where is the edge, right? Once again, we saw there are different levels of edge, and the billions to millions to thousands, right, of edge. Each layer will have billions to millions to thousands of edge devices and edge servers, edge data centers, and so on. So where exactly the edge is located? At first, edge devices are things. These are the smarter things, whatever you come across, a code dot or Fire Stick sort of edge devices at home can be considered as a edge device or a thing, Internet of Things, like smarter thing. And it will have the IoT appliance where the router or gateway is taking some of these things, or your smartwatch, for example, right? Our phone itself can act as a IoT appliance for some of the devices intelligence, and it will be further sent to the router or gateway. It will do some intelligence, whether whatever the data we are getting, it has to be sent to cloud directly like this, or it can go to nearby cell tower or regional data center. The intelligence is built in the router or gateway, edge gateway. So where exactly the data will be sent? It can be sent to just nearby cell tower, which will do some processing and come back, or it can go to regional data center for further processing and get sent back. Or no need to send to these two, we can directly send to cloud data center. These sort of decisions can be taken in the routers and gateways. So whatever you see here, the smarter things, it is happening within the LAN premises. This is very important, you should aware. Within the LAN premises is called true edge. This is everyone wants. We don't want to consume more getting into WAN. WAN is resource intensive. It will be cost. It takes a lot of time in milliseconds itself, right? Milliseconds, saving few milliseconds also is utmost important for the application. Some of the time-sensitive applications are real-time applications. So as far as possible, we need to keep it within this premises in the LAN. If we are not able to do, we need to see how quickly we can take the decision to go to nearby cell tower or regional data center and come back instead of sending into the longer distances in the LAN. These are called service providers edge. So the service provider can be telecom company here, or it can be industry clouds or industry-based compute regional data centers, or it can be public or private cloud like AWS, Azure, or Google Cloud here. So based on the distance, it varies. It is the true edge is within the LAN premises. Anything beyond WAN premises, within WAN also, we don't want to send it to further distance. We will leverage the telecom service providers to help us. If there is no cost, we need to go to cloud. It may take further delay, maybe as I told, 100 milliseconds or so. So these are based on the location. So one devices are here. These are appliances. Sometimes network. It will go to these are network service provider. These are the data centers from the industry, or the companies so big enough, they will have their own regional data center. They will not go back to the cloud. Okay? They use SD-WAN sort of thing so that it will be quick enough to send the requests and come back. So they will send it to the cloud and maybe wait for longer duration. As I told you, if location is farther, latency will increase. So this is what this picture shows. Here, video or healthcare monitoring, drones, energy. Within the devices, if process happen, less than 1 milliseconds. And if you go to nearby equipment, like smaller cells or other on-premise router or other things, it will take maybe less than 5 milliseconds. If you go to little bit further with the data centers, other thing, it may take 10 to 40 seconds, network edge. Okay? This is where the telecom edge or telecom service provider is coming. If further we need to go on process, it will go to network core and it will go and hit cloud computing. So network core to cloud computing, this is actual cloud premises. This will take 100 milliseconds sort of thing. So as far as possible, this is the driver for edge. We need to limit all our processing within this premises, on-premise or network edge, so that we can get the performance and the response time, load balancing, as I said, to the applications on server for higher performance for all the devices from this edge. One is on-premise, other one is network edge. So further definitions, you could have been heard near edge, far edge, right? The definition is very, very simple. Just remember this. If it is the cloud computing, farther from cloud computing is called far edge. Near to the cloud computing, the power, it is called near edge. So whatever the edge, the smarter devices are there, if you get into the device edge and gateway and other computing edge on-premise data centers, we saw layers, regional data centers, the different layers we saw, right? If it is closer to the thing or the people where the whoever is asking for the information or something, or devices, smarter devices, so it is closer to this place, but farther to cloud. Why it is called far edge? Far edge is with respect to cloud. You have to take with respect to cloud, it is far, but near to the things where it is happening. Action is this is far edge. Other edge, the devices itself having some intelligence, some processing power. And all, right? Adreno also have a microcontroller and some processing power. Those things also can be device edge. And on-premise edge, it can use it in the home.
This conference will now be recorded.
Cloud computing resources being distributed to telecom edge. So these are some of the computing power will be kept at different telecom service providers, because first time they are from edge to telecom, this is the first place they are touching, right? they are not going farther. Within that process itself, they are putting some computing capacity so that response and other things time will be very, very less. So further down, if you go, that is the actual traditional and cloud computing capabilities. So this is the based on the distance, 4 layers, and based on distance, how it will be called device edge and on-premise, telecom edge, and the centralized cloud or traditional cloud. Again, there are 3 types of edges. Okay, I'm just giving a lot of definitions just for your consumption. You might be overwhelmed hearing these names when you get to hear about edge computing. So there are 3 types of edge computing. You also hear far edge, near edge. You saw, right? Farthest from the cloud and nearer to the cloud. You saw that. Okay, and similarly, there are 3 types of edge: micro edge, and thin edge, and thick edge. Here also, whatever the edge devices having some intelligence doing the processing, it is called micro edge. It can do very small limited processing, right? It can give some beep, or it can do a vibration. Your smartphone can do a vibration if something not going right direction, right? So that sort of sensors and devices can be act as a micro edge. If you go further, any controllers and like rotors or even Wi-Fi rotors or controllers, these things can be your thin edge. If anything, if you go to thick edge, more capacity. You have high-end computing and on-premise data center. Sometimes you are sending to cell tower, which with computing capacity at its base. I told you in the past, right? These are all thick edge. Thick edge is more capacity. Thin edge is limited capacity, but better than this micro edge, right? So these are the levels of compute and levels of services we can offer. These are called micro and thin and thick edge. So distance would be, it is less than, like it is not even, right, 1,000 of kilometer we're talking about. Here, it is about 1 kilometer, right? The thin edge. 1 to 10 kilometers, it can go to cell tower nearby and come back and I'll quickly do processing. It can be thick edge. Anything beyond 10 kilometers, it can be cloud computing. Hope you are clear. Too many edge taxonomy I told you. To summarize, there are user devices, and at the one end of the spectrum, and it will have multiple layers of fog or edge computing. Fog is small group of intelligence being built with the different edge capabilities. Can be called as a fog computing, right? It is nothing but bringing the capability, right? The for one service, it has to go and touch 2-3 devices and come back. That sort of cloud, smaller clouds being created closer to data source is called fog. So this fog computing, lot of fog computing will be there. They are also interconnected again through routers and so on. So these are the small base stations, and further interface can be regional data centers. The macro can be regional data center at the tower, as I told you. These are the bigger ones, or some of the regional data centers in the premises also, branch, another thing. And if you go further north, you will see the data center. So this is the spectrum. First, outer edge, then middle edge, and inner edge, and core. So outer edge will have a lot of gateways and other thing, right? And with the devices, and it will go to telecom thing and middle edge, and it will go to the further the core database of telecom. The core telecom also will have the traditional data centers. They will have telecom data centers, and they also go further for the cloud. VRAN sort of technologies coming into picture. So these things are inner edge and core. It is once again with respect to cloud technology. With the cloud, closer to cloud is inner, other one middle, in between, and outer. Right, far edge and near edge sort of definition. Here outer edge and inner edge and middle edge. This is the topology. They're all interconnected. Certain times, certain data processing can be done within this outer edge itself. certain processing, it needs to go to nearby the middle edge, and it can do the processing, come back. And further, it has to do some processing. It can send it to the inner edge, or sometimes through core to cloud. So it is all interconnected. Once again, to put it in a simple way, we have a lot of endpoints, and it will go and hit edge in the middle. It can be a gateways, or cell towers, or branch office edge computing devices, or regional data centers. We'll do the necessary processing. If further processing is required, it can go to large data center at the core. That is the public and private cloud. Hope you are clear. The different layers, different nomenclature of edges, and where edge lies in between the devices where the data being produced or data being sensed, and it has to be processed. Okay? The nearest processing can be through edge, through gateway or cell tower or branch, based on the processing capacity required. And if further processing is required, it can go to core. So some processing will be done at branch office. Further processing, it will go to here. It is not like mobile to directly it will come. It can go through this channel also. It can come to branch office and do some processing. With further processing, it will go to core. Sometimes it can go to directly to the core, because branch office cannot have that performance capacity to do the processing. Hope it is clear until this point. So the reference architecture, what exactly you see is we'll have a lot of, this is for industry 4.0, that manufacturing industry. We'll have a lot of ports and equipments at the site, right? Intelligence ports and equipment, and it will go and hit the edge computing. If you whatever data it sees, edge nodes, edge gateway, and controller sensors, and the edge will have different functions within it. It will have an analytics domain within the edge. It can do some processing, real-time processing, and it can also optimize the resources, right? How much data it can do. If as soon as processing it can destroy that service, because it's already got insight, it will only send that insight. So it will have small capacity of compute, network, and storage. Because it has to do the processing, all the three is required. And if you go further, the edge nodes and other things to be managed, we need some orchestration, right, to manage this edge and other thing. And this edge manager is required. And we can have model-based business orchestration. What it would say is, when you go to port and we have edge, sometimes it can go to port, or edge node will decide, or your router will decide, or your orchestrator will decide, yeah, it can process through only edge, or it can go to your cloud, or it can be processed together. Some process here, some process here. The sort of orchestration, balancing the business process can be done through model-based business orchestration. And the direct resource caller, so directly it can go here. And from there it can process through edge or cloud, and it will come back. So if you see the services framework, the services are happening across the board in different layers. And edge, one thing you should understand from this picture, it has analytics portion, and it has some optimization portion to save the resources. We have limited computing network and resources. It has to be always optimized so that it can give best of your abilities and services. Otherwise, we'll miss it out. So optimization is important. We'll not share a lot of data. We'll not do unnecessary computation. Some intelligence is required. A lot of analytics is to be done here, and those things. This is the reference architecture being built for edge computing. So this is the eye-catchy slide. I'm not sure you're able to see. Only I want your attention to see only very few things. It is IBM's reference architecture for edge computing. Sensor, it has AI services inbuilt. Okay, one layer, edge server and gateway, right? Other things. We have edge analytics here. So lot AI modules here. So what we are doing here is, as soon as sensors go to the edge data, we have to do some processing. It can be AI model service, AI services, or some analytics, simple analytics we can do. And any edge applications it has to act, it can act. Other one you are seeing is the Docker, other things, Kubernetes. I'll cover in a minute on those details. These are all the newer evolution of virtualization. We look at what is Docker, what is Kubernetes, how it is helping in the edge computing. So the point I'd like to make here is intelligence has been built in every layer. Okay, every layer, analytics, AI services there everywhere, so that whatever data you are sending, it can do some intelligence apply, and it can send some signals back. Right here, signals back to the sensor or actuators to act upon. Right, we are sending the data. It is not one-way traffic. It will be two-way traffic. Data will be sent, and we want some insight or action to be taken, so that that action will be sent back. It is a round trip. So the round trip can be to the small nearby edge, that is far edge, right, or edge server, or edge network, or micro data center with the telecom provider, or hybrid cloud. So these are all interrelated. It can, one process can go from here to here, then here to here, and this one step better. One process can go here and directly go to cloud. It can go through process one by one, or it can go directly to the thing based on the gateway and intelligence decision made here. Oh, this cannot be processed here. Directly it has to go to cloud for further analysis. It will be sent to the cloud, and the decision will be done here. It will come back to the actuator. So this is the reference architecture. We saw these are the two reference architectures. The key takeaway from those reference architecture is intelligence and optimization built within that. So having said that, what are the key technologies with the so they have close affinity to the edge? We have to look at it. I'm sure you heard about microservices architecture. Are you? So microservices architecture, we are talking about the UI and the business logic and data access logic. Everything is in monolithic architecture. It is processed. It is there saved in one server, right? Single node or single server, and it is not decoupled. Okay, it is closely integrated. If something happens to one area, it will impact entire application, right? Here, it is not decoupled, closely coupled application with user interface to business logic and data access layer, and it is sitting at one server, right? This is also important. Single source, right? It is sitting at one place. If it fails, application cannot be accessed. Sort of. What is microservices architecture? So we'll be having UI. UI can access different microservices. These microservices divides the business logic and data access layer. Different thing. Okay. Few microservices are business logic. For when I say BE, assume that it is business logic, right? And for further the data here. So few can be for data, few can be for business. What is happening here is, if this business function required any data source, it is pulling this data. This microservice can talk to this microservice and bring the data, and both together can go to UI and give the application experience what user is seeking for. So this is microservice architecture. So we are distributing our business logic and data logic into different microservices, containers. We'll get to see that what our containers is, and they are sitting on different servers. They are not different nodes. It is called as a container nodes or Kubernetes nodes. We'll see in a minute. So they are not sitting on the single server like this in the monolithic. So if something happens to this service can continue. Okay. UI have 4 options. 1, 2, 3. Assume that. Okay. if this is the first service, this is the second service. Okay, they are all connected. Assume that this is second service, this is third service. Okay, this is the first service. If this is something happened to this microservices, this is not working. First one is not working, but still user can use these two services. Whereas in this scenario, everything is, your system is down. If you go to any government office, they'll say server is down, sir. Right? So because the monolithic architecture. So if modern enterprises are not at all going with monolithic architecture, they are always going with microservices architecture. And microservices architecture, as microservice architecture, very good portability. We'll see how it will give the portability. It is container technology like Docker. This is the Docker, right? And provides the scalability and portability. So if something happens to this microservice, if you have orchestrator like Kubernetes, it can spin off another microservice with the same features and other things, so that it is available in seconds, in fact, okay? So that this service can be again brought into the live very quickly, so that user is not facing the disruption more than a minute sort of thing, okay? Whereas here we need to debug whether it is a business logic problem, is a data logic problem, or where it is stuck, right? Here we know exactly, oh, one is not working, it is between these two. They have some Kubernetes sort of intelligence and other thing. They know, oh, it is happening in this data layer. So they'll quickly go and it will automatically spin off, okay? It is now manual intervention is required. It will automatically spin off the new microservice, so that this business can work with the new microservice and enable this application service for the user. So this is the microservice architecture, very, very important. All modern day applications are using microservices architecture. I'm sure you know very well this part, okay? And again, containers and Kubernetes. So what is containers and Kubernetes? We all know virtual machines are virtualizing the hardware until hardware layer. Okay, we are getting into hardware, your storage, infrastructure, networking, security, other parameters has been compute, right? Compute, storage, and networking, along with the security parameters are virtualized here. And on virtualized environment, we have to put guest operating system of your choice, and related to bins and libraries of applications, binaries and libraries of the application, and which are required for application A to function. So we'll create a virtual machine with this sort of binaries and guest operating system. One can be Windows, other can be Linux, other can be iOS, for example, right, for Apple. And the bins and libraries related to that application, so that this environment infrastructure can be leveraged for different virtual environment. But every place we are putting guest OS. What will happen if it has tightly integrated with guest OS, right? This application binary library can work with only this guest operating system. It cannot, it has tightly integrated with the operating system here, or software virtualization of guest operating system. Whereas in containers, if you see here, the operating system, assume that your computer or server with Linux or Windows, right? And we are virtualizing that environment. And the container engine will help you to create multiple containers with the bins and libraries, which are helpful for the application. So when I remember the earlier one, microservice architecture, the business logic, so it can create the binaries required for the business logic and the application. Similarly, the data layer, if any database libraries and other things required, database tables and other schematics to be required, it can create in another container, and other application in B. So multiple or BD. Assume that some containers will have both business and development also. It is not always B and D to be segregated. Sometimes if it is a smaller database interface is required, it can be clubbed into the application layer itself or business logic itself. So these containers, the advantage is portability here. Here, the application A cannot be, if I have Windows laptop, tomorrow I am purchasing the Mac, the iOS operating system. I cannot port my application, right, whatever software, to the Mac directly, right? Because it has, this one is virtualized, but virtualized with the Windows software, Windows operating system. I cannot port it. Here, the application is there independently, irrespective of the operating system. Today, I am hosted onto Windows. Tomorrow, I can host it onto Linux. No problem. Because there is no tight integration here of the containers. So this is the difference, the main difference between virtual machines and containers. Hope it is clear. So it is independently work on the host infrastructure, okay, where it is hosted, independently can work. There are different types of container technology. We heard about. Any question? Okay, I think someone has to go on here. Type of container technologies, right? Kubernetes. You heard about KAX. I think someone has to go on here, please. Yeah, thank you. So Kubernetes, it is open source container orchestration platform. Containers, okay, one disadvantage, if you call, right? It is not disadvantage. We give more flexibility creating containers. Containers are very easy to create. People tend to create more and more containers for their applications. Assume that today I created 10, tomorrow the enterprise grown further hundreds, thousands, right? 10,000s of containers in the enterprise. It has to be orchestrated, right? Which container people should not duplicate containers to be created, right? Or where it is to be deployed, which hosting system, right? Or those things can be operated through Kubernetes. So in the Red Hat scenario, it is called pods. Okay, they will have the storage and local networks where group or one or more containers. Okay, one or more containers will be placed in a pod. Ideally, the best practice is one container in one pod is the best practice. But the option, we have option to create multiple containers in the multiple pods so that we can manage through Kubernetes platform. Like Red Hat OpenShift is the Kubernetes platform. We can manage the hundreds of containers through Red Hat OpenShift. So this is the one Kubernetes we call, right? The Kubernetes have clusters and all. Clusters can define 3-4 related containers into one cluster node, and then that node can be managed through Kubernetes platform and so on. This is the Kubernetes. It is simply called as KX. Other one, similarly, the public clouds also have their own container service, right? Which can spin off ECS, ECS. For example, container service, EKS also there, electronic Kubernetes service. So AWS can help you to spin off containers, also manage the containers life cycle, right? Through Kubernetes system, EKS. So they have own Kubernetes architecture and container orchestration. Other one is AKS. Azure also has its own. Red Hat provides OpenShift. This is also one important technology. So these are all the different KS you saw Kubernetes thing. And there are another distributions of Kubernetes which are lightweight in nature. You need to understand, very important. Kubernetes are created for enterprise kind of applications. When it comes to edge, we cannot have Kubernetes kind of software which is quite heavy to put it onto our servers, edge servers, right? Edge servers, as I told, minimum processing it can do and all. We want something lightweight. So there are many lightweight Kubernetes distributions being created based for the edge and IoT revolution. These are all K3. These are all once again open source. It is called K3s. K3 is the tailored version of K3, right? With help. So it is the lightweight distribution, certified distribution, and which will help to manage. Okay, this sort of distribution we can put it into some edge server, and it can manage as a hybrid. Okay, it can interact with the Kubernetes in the cloud, and also it can do the microservices functionality for edge computing also. So Rancher Labs is one of the leading company who has lightweight Kubernetes, and similarly Red Hat also come up with their device edge, which will use K3s, and AKS Microsoft also come up with AKS Lite. AKS we saw just now, right? Azure Kubernetes Service, that is for enterprises. AKS Lite for the edge computing sort of use cases. And KubeEdge. KubeEdge is nothing but it is also from the open source. It can do the small server will be there. That's why it is called KubeEdge, right? Kubernetes sitting on the edge thing. Other one is micro K8s. This is very, very small. We are thinking about micro K8s can be in the sensors, your mobile phone, right? Very small computing capacity devices can have this micro K8s, can interact with containers or microservices easily. So K8s can talk to K3s, K3s can talk to K8s, and so on. This sort of hierarchy created the lightweight, very lightweight. K8 is a very lightweight. And other important technology you should understand, you'll come across for the enterprises is taking public cloud offering into your own office. For example, right, your office is here. Okay, your office is here, and cloud is sitting somewhere in the region, east somewhere, US East you can call. Okay, sorry, it is East. So US East. You are sending your processing here and all. You assume that here you have Azure. Azure cloud is there, and you are sending to this Azure and coming back. But certain data loads, what is the edge thing? We don't want to send it to Azure, but we need to have the nearby some data center, which should help them to process. And if required, only they can go to Azure, the public cloud. So what is happening is, they can create their own. As a company, I can create my own data center here. Other option is, I cannot replicate all the services being provided Azure here. Otherwise, I am creating another small subset of services of Azure here, which is of waste of time, right? What Azure and AWS, even IBM come up with, they created small appliance sort of service, okay, like a Birva, right, sort of thing, bureau, which will have some racks stacked here, which will have the computing capacity, and will also have access, direct access. It is called interlink direct connect in the AWS and Azure. That is fiber optic access will be there for this to this and cloud directly. These devices can sit in the premises here. These devices can sit here and can interact with Azure. This will have miniature of Azure cloud sitting in your premises, right? Your enterprise premises, so that you can leverage the services of Azure and process it in person. And it has highway connectivity. It has direct connection here between these two. So direct connect and those things, it is called interconnect and direct connect. Route 43, those are direct connect. So it will be fiber optic connection, not through internet or wireless connectivity and cell towers and all. Okay, and these are all very important. These are also enabling so distributed cloud. So this is the one of the pillar for distributed cloud, right, for enterprises. So you should remember the names. Outpost for this from AWS, StackHub. Other one is Edge Zone or Azure from Azure, and IBM Cloud Satellite is from IBM. Google Anthos is the multi-cloud management platform from Google. Provides this sort of services to closer to the premises. What we are taking is public cloud capability. We are bringing it to your own office. This is what we are doing. We are bringing edge to cloud architecture platforms, okay, or cloud to edge. So whatever cloud is there, we are bringing it to the edge to enable it as the architecture. These are the platforms or companies already helping the enterprise to do that. So one point I always making, right? Distributed cloud and centralized and decentralized. So quickly look at what is centralized, what is decentralized. Centralized is everything, whatever data has been produced, it is going to cloud and coming back. We don't want that. Decentralized means whatever being computed, it can go to nearby. Data is produced here, and data response also needs to come back to this device. So it can go to nearby fog computing or edge devices, other places. It can come back. Okay. Fog computing will have the group of edge devices and edge products, and doing the services for this mobile application. Assume that. So this is it can go to nearby fog or edge device and do the process and come back. Similarly, the camera, it is capturing the say road stay or other or the signal if someone is violating or not. It will go to nearby signal and it automatically can give the signal saying that so and so car vehicle being violated, crossing the red. Okay, automatically the penalty being sent to that car owner through mobile or whatever, right? So processing can be done quickly here, and the decentralized and car also can take the decisions, intelligent car or autonomous car. These are all decentralized thing. What is we are doing is data processing. We are not sending it to the cloud. We are decentralizing locally. It can do. This is called decentralized, and it can happen hybrid. Okay, this is the model everyone looking at now. Decentralized has its limitations. It can do only single function or limited functionality, and centralized has its own limitations. You know, latency, performance, other thing. All the data what we are producing gigabytes cannot go to cloud and process real time, right? So in the cloud, if something happens to cloud, all this functionality of offering the not okay. Right? Here, maybe this will not be infrastructure, not in one place like cloud. We are distributing.
Will now be recorded.
Decentralized. This is the one of the core technology or underlying aspect of edge computing to be getting famous. Right? You also get to hear Web3. Web3 is being coined as a next feature of internet. So we know Web 1, Web 2, Web 3. Okay, let's see. All e-commerce sites we used to create like dedicated infrastructure. Everyone will have their own infrastructure created before prior to cloud. I'm talking about, right? And on-premise data center. For example, Walmart, they will have their own data center to cater to all Walmart stores and so on, and for all e-commerce services they can offer. That is Web 1.0 technology. What is Web 2.0? Where we got into social network and mobile first. So everything is mobile first thinking. Cloud is enabled that sort of Web 2 technologies. Here, Web 3, we have a lot of AI driven. Something we sense, we need to immediately intelligence to be insight to be and it has to act upon. It is decentralized. It is not going back to always cloud, right? It is decentralized. This is called edge computing. It has been leveraged and do it. We cannot do anything as a user. Here, you can read and write. So we are talking about Facebook, another thing, right? We can also interact with the internet. Our data can be put, right, onto someone's infrastructure. Someone, you have given the option to publish your blog or article or put your photos, upload, right? You can read and write on the internet. That is the Web 2. Here, you can read, you can write. What else we can do? We can own. Okay, this is important. We can own. So here, Web3, what we are having is we are decentralizing and demarcation. Like we are giving the ownership of internet to the users who are producers the data. You can own the data also, right? That is what we are talking about. So you'll be the owner. If someone started using, for example, today YouTube, you uploaded a video. If based on likes and a lot of visits, you get some money. Assume that, right? That is happening. That is the financial model of YouTube. In the near future, you have an option where you can upload your video. You can monetize for your own data itself, right? You can create some services around it. You can monetize. You will not be depending on Facebook. Why they'll paying money to you based on visits and all? They get some analytics done behind the scenes. That analytics data can be used for some other purposes. They are giving money to you. So whereas in this Web3 technology, your data, you can do analytics of your own, okay, and you can monetize that service and put it onto web, back into web, and if more people are taking, you get more money. You can create a Facebook of your own in near future with Web3 technology. Okay, this is the Web3. This is also distributed and decentralized data architecture, and where edge will play much higher role in this, and edge computing and metaverse is also one of the place where we get to see 5G and Web3 technologies with edge computing coming together. Okay, I was always talking about MEC. It is earlier called as mobile edge computing. Today it is called as multi-access edge computing. The access to the edge, right, data center, which can be telecom provider, base or something, or within the data center, it will have gateway and some MEC servers. It can take from multiple access points. Okay, it can be from phone or your server, some intelligent devices, Alexa or Echo Dot or something, or your mobile or those things. It can take the data from multiple access. That's why it is called multi-access, and it can get it to the servers, and the servers have intelligence to say that it can process here, or it has to go through core network, or it has to go to centralized cloud. So it will do the routing of the data from based on the intelligence in the MEC server and can send it back. So the cluster of edge, this is the true edge, right? True edge services can be provided through MEC server. It is nothing but extension of cloud sort of services within the edge compute capacity, right? Smaller cloud, which will have the capability to do many processing, 50% or 70% processing. If required, it can go to the centralized cloud. This is called MEC. So multi-access edge computing and mobile edge computing. It is becoming more and more prominent with 5G technologies and other latest use cases, industry use cases. So the 5G provides the network infrastructure deploying the MEC. Other key technology, we talk about fog computing. Fog computing is we have a lot of devices. It can go to the servers, gateways and servers sitting, and they are interconnected to do the one service or multiple services for this thing, okay, Internet of Things. One fog can talk to another fog also. This is also there, right? So fog computing is cluster sort of thing, clustering of services, computing power offered to do certain process, and it can integrate or it can be independent also. These are all fog computing. Fog computing, as I do, is a smaller capacity cloud closer to the data source. That's why it is called fog, and do the processing. The edge servers and all falls under this regional data centers. Edge servers falls under this fog computing within the LAN premises. Okay, this is also very important. Within the LAN premises, we do anything beyond LAN, it will go to core network and internet. You also get to hear about cloudlets. Cloudlets also, it is nothing but servers like this servers. sitting in between thin clients, right? It could be mobile or your phone, mobile phone, with wireless router connectivity. It will go there and it can do the server. It will act as, so assume that you have a coffee shop. You went to a coffee shop, you ordered a coffee. It has to send some alert to the serving team, right? So the cloudlet can do the serving, like the alert. And if number of orders per day or something, it can go back to cloud server. But all alerts and other things you can do from cloudlet. Cloudlet is nothing but smaller compute, which is lying between cloud and thin clients. This is the cloudlet. Other one is micro data center. Micro data centers are, these are highly mobile and rugged, very rugged design. Right? You see, it's like a strong room, okay, where the servers will kept inside with maintenance and other thing, and which will act as a like micro data centers. It is called micro data center or regional data centers, which can do the much more computing capacity, right, compared to all smaller edge device and edge servers. So these are much higher capacity things lying in between your data source and the cloud. So one thing is common. If you see all the places, we are bringing some additional capacity in between, right? Whatever technology you say, here we are bringing the micro data center. If you see here, we are bringing in between cloud and the things clients, we are bringing cloudlets. Here we are bringing fog computing. Here we are your things and the central cloud, we are bringing the edge cloud computing. So something, the different options of bringing computing power closer to your clients is edge computing. As simple as that, right? There are different means to get the services. Those are, be it MEC servers, micro data centers, and cloudlets, and so on, right? So this is what cloud are. Something powerful capacity, bringing the capacity, computing power, instead of going back to always cloud, bringing closer to the data source is the edge computing. It requires a lot of skills. Okay, if you want to be, say, I want to cater to the edge, like Storm, right? A lot of IoT and 5G, other technologies coming together, AI technologies, and a lot of data explosion is happening. What you have to do is edge solutions will come into reality. I told you the 250 billion I'm talking about by 2025. That much business is coming to reality, and the skills, it calls for different varied skills. Okay, not one skill. One is internet thing, right? You need to have internet protocols knowledge. You should have hardware, sensors, and cloud servers knowledge. You should have cloud native skills and IoT and other microservices architecture, container architecture I talked about, right? These are all required. You need to understand this cloud technology, microservices, container technology, orchestration, and cloud native services, IoT and edge services offered by the AWS, Azure, and so on, right? And the IoT edge computing, and what are its applications, right? Which edge server can be more appropriate, or which PaaS application more appropriate to build which application edge service. Those sort of things can be got into IoT edge thing. A lot of intelligence being built, so we need to understand the deep learning. Okay, for example, there is a computer vision, a camera been kept in the shop floor, and there is like a steel manufacturing is happening. For example, Tata Steel, we did one project. Tata Steel creating steel rails for Indian railways, right? Railway track. So it will come with a different size and different density, other parameters. And at the same time, it might be defective. It is a very micro level defectives can be there. So they kept high density cameras closer to that platform where the railway tracks being produced. And if you sees any hairline fracture sort of thing, very small defect, it has to stop the production and immediately address what causes that production and retake it. So there, a lot of AI, computer vision, AI, along with IoT and edge computing has been leveraged for Tata Steel. Similarly, Cosmos database is a very powerful. There are multiple databases, but Cosmos, because distributed database, is very opt for edge computing. And we see this is a MQTT, the message queue protocol for lightweight message protocol being leveraged for edge computing and SD-WAN, Ethernet and Bluetooth technologies, and software, of course, a lot of security. The skill, one of the key skill I recommend to your students is a Python, probably C++, are very, very critical to learn. It is not only for AI, ML technologies, it is also for 5G and other edge computing solutions. These become very, very relevant. So Python, C++, and understanding some of the device and its drivers is very critical for software thing for students. So the intersection of skills, we require software skills, we understand hardware, what are the middleware, cloud and digital. So all these technologies coming together, creating multiple use cases for edge. So the edge use cases are to different industries. Retail, we can give the better experience to our customers. As soon as they come and watch, it can greet them, and they choose one dress. Okay, as soon as they go to the mirror, intelligent mirror, it can show them as if they wear that dress, and they can see without wearing itself. As soon as it identified the tag of that dress and your structure, right? Automatically, it will take intelligence AI intelligence. It will take the dress as if you put it onto you, and it can show it to you. Immersive experience of you, or any of the product being sold quickly, right? It is not available. It can look at, like computer vision, other things can look at it and give alerts to the back office so that it is not out of stock sort of thing, right? If it's getting out of stock, automatically you can bring it back so that supply chain efficiency can be increased for retail. And smarter cities, many applications being the security police thing to the intelligent light, traffic lights, intelligent lights, right, street lights, and so on. Automobiles manufacturer, industry 4.4. One of the examples, as I pointed out, Tata Steel and autonomous vehicles. So it is a long shot, but when it comes to reality in India and other countries, the 5G and edge computing will play a major role. Healthcare is a very, very important use case where a lot of healthcare devices are capturing important information, but they are not talking to each other. For example, someone taken the BP parameter, your glucose, the levels, and it is been not given to the other parameter, right? It is been taken, marked as a separate independently. Someone doesn't know, right? They looked at 1 hour back, and there are some other parameters change, and someone don't have that access knowledge, the doctor or specialist, he might have very difficulty to give the decision making, right? Which will help shoot up or bring down your sugar levels also. So having all the information are tightly integrated and given at one place, edge computing helps. There is a healthcare thing. Logistics, we look at it, and telecom companies also have their edge servers, and online gaming and streaming, immersion through AR, VR. It is called Extreme XR, right? Is the immersion experience is also coming into play into gaming and video streaming. These are some of the use cases from NASCOM. This slide is from NASCOM. These are the different use cases. I'll not take very long time, but let me see some of the things, right? Patient monitoring and telemedicine. Not the specialist cannot be available nook and corner of every place in India, right? Of the rural places, assume that. So we can have some edge computing device in that place in the rural health center. If you go there, and automatically on the mobile tablet, people can interact with the specialist. They can provide the telemedicine based on some of the monitoring
or parameters being captured from the rural health centers. A lot of machine learning, diagnosis, medicals, okay, images. If you have the image being taken, people usually put it in the back of the light and they observe, oh, this might be a problem, right? As soon as an image you give it and give it to the machine learning, it will go and say, these are the possible malign defects, okay, in this, or observations on this image. It can say, doctor will use that machine learning insights, can take a decision, okay. He will have his abilities, is enabled. It is not a replacement for the doctor, but doctor can get additional information from this machine learning. So very important. So these are sort of healthcare services can be provided. In the transportation and airlines and other thing, automated baggage tracking can be done. And container management. If container is started from one place to other place, you can know exactly the container capacity and what is inside, whether it has been safe, where it's stuck, where it is coming, and those things, and fleet management and the package tracking. For example, you have the pre-packaged food item. We see one example here, how the package, whether the items within that package is still consumable or not, and so on, right? Those sort of things can be done. If any maintenance to be done, proactive maintenance can be done, offered through this edge computing. Agriculture is a very, very huge area. Today, we are talking about, it is 15.1 billion business today for agriculture, where edge being leveraged, IoT devices and edge being leveraged. We look at one of the use case. They can monitor the soil condition and what type of pests, if is observed based on the leaf color or other issues. For example, they put sensors to temperature and moisture content to observe, humidity, moisture content to observe. If they see watering to be done, they can do precision farming, right? They can do the soil based on soil condition, precision farming. Other one, pest control. If they see some of the leaves are decoloring, or they see some white patches or black patches or yellow patches, they identify exact reason what causes that. They can do the pest before it is spreading across the farm. And other thing is livestock also. They can track the health of the livestock, everything to be done, and so precision farming, other thing. This is a very huge business. Manufacturing, I told you, industry 4.0. Lot of things can be done. Maintenance of the factory and soft floor displays, predictive maintenance. Okay, they can see the whatever manufacturing facility each one, and instead of it getting failed, right? After that, taking the reaction and stopping the production, they can see predictive maintenance of the product manufacturing units. Other one, any fault, like Tata Steel example, can detect and troubleshoot immediately what caused that problem and address it immediately, so that the entire production is not being wasted. So as and when we find a problem, immediately they can find a problem where it occurred and address it, so that next batch will be right batch of production. So inventory management, what it required and all, you can do. Automobile, aerospace, we can take connected automobile cars, smart airports. In Bangalore, where I live, we have the smart pass for the boarding pass, right? A boarding pass for the passengers. As soon as I enter, right? If I opt for that service been 2-3 months back only, it has been rolled out at Bangalore airport. As soon as I enter, it recognizes my face. If you go to that place, okay, they have designated space in the Bangalore airport today. If I go there and I opted for that service and I go there, as soon as I saw my face, it knows, oh, Sridhar, welcome. So this is welcome, and are you ready with your boarding? Yes, I say. How many bags you have? You can go there and click it. Automatic, everything, like you are not going to the queue and waiting for your boarding pass and all. Automatically, boarding will be sent to your mobile phone. Okay, and you take that mobile boarding and show it to everyone and enter it. Not even printed. Okay, everything is human and edge computing and IoT and computer vision being leveraged for that. Kyndryl, we did a lot of prestigious projects with them, and we've been doing additional innovation projects with the Bangalore Airport, BAL. So this is one of the use case. Other one, utilities. We have a lot of smart grids. For example, electricity, oil production, right? So we cannot afford to lose power for longer hours, or water supply to the city. Those things can be monitored and addressed locally. So that is one of the use case, critical use case. And telecom services, we said CDN, right? All the OTT and other services, not only to, for example, recently the soccer, right, FIFA football thing, it has been offered on Geo free of cost. So first 2 days it was very pathetic, right? The lot of disruption to the service, I'm not able to see. Okay, and some of you could have been experienced same way. A lot of my friends also experienced. It was not great experience on the Geo platform to see the streaming of live matches, because it is not coming in interruptions and all there. Later, I think they got a lot of complaints. It is came in newspaper also. Back end, they did a lot of CDN improvement, right? Optimization, other things, or more servers they could have been deployed. Now it is seamless. You can see the FIFA World Cup matches live on Geo, seamless, no disruption, nothing. So that can be possible with a cloud and edge and CDN, edge CDN kind of services. And banks can offer customer care and safety also. If someone comes to cheat the bank, they know exactly this guy, what might be his intention based on his computer vision and other thing. They can take some alerts and precautions in the banks. Retail I already covered. Advertising industry also, location-based advertising. When you are entering to the airport, or when you are entering to the Hyderabad, for example, right, or Bangalore, people will know you are in Bangalore, and they can send the it is the lunchtime. They can send the coupons related to local restaurants with their feedback and coupons to you. So that sort of local-based advertising can happen. And media and entertainment is the very big use case for edge computing. So video content delivery we saw, and gaming is another thing. Gaming is not individual gaming; it is the like multiplayer gaming sort of thing, and they require a lot of fast thing. Multiplayer is very important. And smart infrastructure, like smart parking, smart traffic management, those things can be done. Smart homes, everything is becoming smart. So those things can be covered in the smart infrastructure. So these are some of the use cases. Okay, these are the different players. We see global players and Indian players also. All the companies you know, this is not an exhaustive list. Some of the list of companies, NASCOM presented. So Infosys, Tata, Cognizant, SCL, Geo, everyone has their services in cloud, and IBM, Azure, right, and AWS, and has the services around, and they also have hardware. So there are hardware players just providing hardware for edge devices, other thing. Cisco, Hewlett Packard, network, right? When I say network connectivity here, network hardware, for example, Cisco, Hewlett Packard, Intel chips, right, for intelligent devices, Dell AMC for larger enterprises. The providers infrastructure can be AWS, Google, and Rackspace, and these are some of the solution providers. Nutanix is the very prominent in this space. Okay, Nutanix, you should understand. And these are all Indian players can cut across. Okay, they are not limited to only services. They can partner with Cisco and provide hardware build services, also network services, and the managed services of edge computing. They can do. All these companies can do. Kyndryl also one of them. We can do across all the portfolio. Okay. So seeing the healthcare, I already covered healthcare, what exactly doing. So the patient is here, the monitoring and temperature, other things, the sensors, that information can be sent to local gateway and local server. And if the intelligence or decision making can be sent it back to the respective stakeholders, what action to be taken, right? Or if required, it will go back to cloud and it will go to the cloud hospital data management system or the doctor to take the call. Sometimes this alert can be sent directly to the doctor. So this edge computing comes in the middle, helping minimize the load on doctor and also address any immediate concerns for the patients or emergency situation where we need to act immediately. This can be done, right? Someone, okay, this Arduino, Raspberry Pi, I know a lot of colleges we use and teach some of the AML and IoT sort of projects. So these things are very predominant in industry space also. Such sensors can send alerts so that to the respective, for example, your car has the intelligent device, but it met with an accident. It has to immediately inform to the police station, nearby police station and hospital and emergency services division and your insurance company and so on. So all the intelligence here, right, in your vehicle can trigger to the alerts to the police station and the insurance company and hospital and the ambulance services nearby and so on, so that you've been saved from that eventual unfortunate situation, accident. So a sort of healthcare system can be provided. And other one I told, remote healthcare, telemedicine is also provided in this space. Other important thing is smart grid. Smart grid is nothing but we produce a lot of power, example, electricity. It will be consumed for factories and the houses and power plant, the houses and factories and so on, right? Or electric cars now, more and more electric cars coming. It can be produced for hydropower, nuclear power plant, thermal, wind power, solar plant. That these are all producers. Okay, this batch is called who are producing this thing. So sometimes, while production itself will be losing the demand supply, electricity can be stored to the extent, but it cannot store all the production every time. Okay, we should produce the to the limit how much you can store, how much you can distribute as a electricity thing, right? From these different things. So the smart meters and other things can be there here. It will observe the demand and accordingly it will produce the power and okay, power will be in the demand city for this region. So it can produce and send it to this factory. Or if there is a stadium, cricket match is happening, and they expect a lot of floodlights, something day and night match, and a lot of people will be using their mobile and other things. All towers needs to be having load, and as well as floodlights and other thing. The nearby distribution center, no, there will be increased load in the evening, and it will send the alerts to the nearby power plant to have enough supply so that it can cater to the needs of that stadium. So these things can happen. Everything is the smart enabled. UK grid, right? There is a smart UK grid institute where entire UK, all the houses and factories are smart metered, and the meters alerts will be sent to the hydropower or power plants. They know exactly what is the demand in real time, precision with the precision can supply, and they know that any events are coming up in that region also. Sort of intelligence being set up, okay, proactive measures, and so that production can happen and store and distribution can happen. So UK smart grid is the example for this space. Other one, gaming, edge computing, right? Once again, a lot of games we are using the mobile network and radio access network. It's called small towers where we leverage depending on this radio access thing, and there might be small servers also sit here, or it can go to MEC servers. This MEC server, multi-access edge server, cloud server, can sit here, right, in the base of the server, right here, which will help not going to the internet. Okay, a lot of caching and other things can happen here, so that your performance is not degrading, and you can play a game to the performance, low latency, and better user experience. Here, one example here, Gen Layer. It is the leading mobile game producer, Singapore, I think. Okay, they have Singapore, and they have multiple countries. This they launched in 2018, and multiple countries. It is a battle, a war sort of game. Multiple people come together and play that game. It is very, very famous. I don't know the name of this game. It looks like it is very famous game, and they leverages the edge computing to address for caching, edge CDN, right, for caching and provide it. And the level of users today is more than 90 million. Users are there for this game, and it is there in more than 20 countries today. So that it started in 2018, and in 4 years they have 90 million plus customers across and 20 countries. It started with 5 countries and now expanded to multiple countries. They're able to replicate the same sort of infrastructure and edge computing to other different countries. Other one we already saw, autonomous vehicles. It is a far fetch. Okay, it cannot become reality in near term, but where we can have a edge in the middle or cell towers, right, having some 5G sort of thing, it can give the signals, always alerts. So some signal is there. Sometimes it can go to edge. Sometimes it can go to the nearby cell and get the alert. So it is a combination of 5G and edge cloud will help you to make autonomous cloud as a reality. And the smarter edge devices on each of these cards also talk to each other. They can talk to each other also. So it can talk to cells nearby, it can talk to edge cloud nearby, and it can talk to each other so that they can play intelligent autonomous without having human intervention. They can take human-like decisions and stop it. Suddenly someone run in front of the car. If they need to apply brake, right, autonomous car, it can apply the brake because it has all the sensors to see someone is running, and it has to apply brake immediately. Okay, and another use case I'll cover in another 10 minutes. I'll close. Right, very important topic coming up subsequently. Maybe I'll cover it within 10 minutes. Please bear with me. And this is the automotive fortune company in India. You can guess who is the company. They have engine like a lot of screw and everything. When it has to engine have fitted into the car, it is a big problem, right? So they have to eliminate problems related to engine assembly, right? A lot of bolts and other engine assembly, they have to look at it. So this company, Ascent Intellimation, is the company who helped addressing this problem. What they do is, while putting everything, they have cameras to capture different angles, how it is being kept, whether it is in the right, the screw is fitting in the right place, this is not right, something. If they quickly observe, they can alert to the human intervention to fix this problem. So earlier, there were a lot of, it was the 93% only the success rate. Around 7% there was a defect. A lot of human intervention is required to fix that problem. Now with this intelligence being built with the edge computing, it got into 100%. No rejections of injections due to nut tightening issues. Everything been accepted. They know exactly how much precision, how much tight it should be, and everything. And the production is not stopped because of these defects and all. So it is continuous. So production productivity also improved for this plant. So it has been replicated not only in one factory, it has been replicated across all the factories for this automobile company. Similarly, very, very important, water distribution, right? So it is a leading manufacturer of submersible pump. When it is submerged in water, we will not know how it is functioning, what is the defect, what could be the causing issues and all, right? So these people, what they are doing is they are checking some of the temperature, moisture, and energy meter parameters. Some of the sensors are there to measure it, so they know exactly what could be current voltage issues and other thing coming to this device and all. They know if they need to shut down because of some issues, they can shut down so that preventive maintenance can be done, and with alerts to be sent onto the dashboard so that they can address what is the exact problem. Otherwise, what will happen is, we know some issue is there with temperature, it is overheating. steel we're producing, that coil may burn, right? We need to change the coil. Yeah, but the problem with heating is not due to coil, right? Some other issue might be there, because a lot of dirty water got into this pumping, and it caused a lot of friction. It caused the heat. So if you're not addressing that problem, and the coil may burn itself, right? It can be dysfunction. This mobile submersible pump can become dysfunction. So these people created a lot of this sort of sensors and sending to edge computing to monitor. Yeah, status is okay. Status is okay. Like not okay, they know exactly this switch has, this sensor has problem. They can go and address it to the core, so that preventive maintenance can be done on this. Okay, this is one of the industry thing. And similarly, food quality compliance. It is a manufacturing food meat company. It is called Tyson Foods in West. But what they do is they pre-process. They cut the pieces and package it, and they put it in a package. Right? What was happening is certain times the package, it has to put one type of piece of leg and one piece of thigh or side, wing or other thing together to one package. So sometimes the sorting and processing it is not able to do. Sometimes the product was not in good quality. Okay, before packaging itself. Okay, these things, what they did is in the manufacturing plant, they put a lot of cameras and HT and see whether this quality is good, whether we are sorting out correctly the package with the required thing and putting it. Okay, all it is been sent to edge, and it is required they are processing through Microsoft Azure cloud. So from computer vision to edge and edge to cloud, they are processing, and they're able to save a lot of rejection from the retailers, as well as unhappy customers. Customers are unhappy, right? If you see, they're supposed to get one thigh piece of leg piece, right? They are not getting, right? It is not there. They got 2 wings instead of 1 leg piece. So people, even though they got extra piece, they might not be happy. They're saying that I didn't get what is been given, right? Picture. So those sort of things being addressed with IoT and edge. This is a very important recent example in Dubai. Bostonica. Bostonica is a very large vertical farm in Dubai. It produces 3,000 kg of produce, mainly like leaves sort of thing, leaf and small vegetables. It is leveraging, it is a vertical, right? You can see it is a vertical, and it is a temperature control, non-pesticide. Okay? Pesticides we come because we expose the environment or other pollution parameters, other things. If it is controlled, it is pesticides, no need to use the pesticides, and we know exactly temperature and other things, how much water required for this is the better